Hi everyone. Entering the home stretch here. Don't hesitate to contact me if you are having a question on the quizzes or about the paper. I've gotten a number of positive comments about the activities and the videos. Glad you like them. And if you find any more along your travels on the web, especially if you find a video that helps you better understand a concept, please pass it along to me and I will use it in future courses. This week the pace doesn't ease up too much as we move into ANOVA and factorial design. This is the meat and potatoes of behavioral research. Many of the journal articles that you are reading and the studies that you are looking at use a version of an ANOVA or a factorial design. So let's get started. Although one independent variable experiments are simpler than experiments that use multiple independent variables, they are not inferior in any way. A well-designed experiment with one independent variable is vastly preferable to a sloppy experiment with many variables thrown together. How many groups should an experimenter use? This question marks the difference between the multi-group design and the two-group design. A multi-group design compares three or more levels or amounts of an independent variable. A multi-group design can have a control group and two or more experimental groups. We can compare 3, 4, 5, or even more differing levels or amounts of an independent variable. A multiple group design does not have to have a control group. A two-group design can tell you whether your independent variable has an effect. You should never conduct an experiment to determine whether a particular independent variable has an effect without first conducting a thorough literature search. If you find no answer in a library search, then you should consider conducting a two-group presence versus absence study. A two-group design can tell you whether your independent variable has an effect. A multiple group design is appropriate when you find the answer to your basic question and wish to go further. Multiple group designs are measured with the analysis of variance, or ANOVA. The ANOVA procedure used to analyze a multiple group design with one independent variable is known as a one-way ANOVA. A one-way ANOVA for independent groups is known as a completely randomized ANOVA. A one-way ANOVA for correlated groups is known as a repeated measures ANOVA. The notion that has evolved for the ANOVA is that we are comparing the ratio of between groups variability to within groups variability. That is, F equals between groups variability divided by within groups variability. When the independent variable has a significant effect on the dependent variable, the F ratio will be large. When the independent variable has no effect or only a small effect, the F ratio will be small or close to 1. Factorial designs are the lifeblood of experimental psychology because they allow us to look at combinations of independent variables at the same time, a situation that is quite similar to the real world. Factorial design is more like the real world because there are probably few, if any, situations in which your behavior is affected by only a single factor at a time. The factorial design gets its name because we refer to each independent variable as a factor. Multiple independent variables yield a factorial design. Theoretically, there is no limit to the number of independent variables that can be used in an experiment. Practically speaking, however, it is unlikely that you would want to design an experiment with more than 2 or 3 independent variables. Once you have 2 or more independent variables, you will use a factorial design. The number of levels of each factor is unimportant at this point. The simplest possible factorial design is known as a 2x2 design. This 2x2 shorthand notation tells us that we are dealing with a design that has 2 factors, independent variables, because there are 2 digits given, and that each of the 2 factors has 2 levels because each digit shown is a 2. Various factors are often designated by letters, so that the first factor is labeled factor A and the second factor factor B, and so on. The levels within a factor are often differentiated by the letter that corresponds to the factor and a number to differentiate the different levels. Thus, the two levels within the first factor will be labeled A sub 1 and A sub 2. I'll put a couple of videos attached to the lecture notes to also help you understand ANOVA and factorial design better. After taking a look at these videos, if you still have some questions, feel free to contact me, shoot me an email, or give me a call. Well, that concludes this lecture for week 6. We're moving right along. Before you know it, we'll be on to week 7 and wrapping things up in week 8. Keep up the great work. You're doing a fantastic job of interacting with one another. Couldn't be more happy with the class interaction as a whole. Okay, that wraps up week 6 lecture. And as always, we'll see you around campus.